next defect, that is hypermetropia. So as the name suggests, long spelling, that means long-sightedness. So the other name for the hypermetropia is long-sightedness. Here in this case, you are capable to see long or far things. Okay, so you are able to see that, but not capable to see near one. Okay, so here we are having the solution for that also, and how we are going to see how this thing is going to happen. Okay, so what are the basic causes of hypermetropia? Again, I am telling you that near thing that is 25 centimeter. So the nearest thing for the normal eye is capable of looking at 25 centimeter. But the person who is not able to see at least this much of one, let's suppose here is the eye and this one is the limit for the normal eye, that is 25 centimeter. Okay, now the person which is suffering from the hypermetropia is not capable to see the things at this position. He is capable to see the things at this position at last, near one. Okay, so near point for them is going to change from here to here. It has shifted from particular 25 centimeter to some distance. So that means everything that is after this place to this place in between is not going to visible to that person. So that here we can say that they are not able to see near things. Now here the causes for this is the eyeball become too small. So what is happening? The light that is coming, because near point is got shifted. So here it may be got shifted. So in this case, what is happening? The light that is coming like this is going to bend and focus at after retina. After retina they are making, so again it is going to be blurred for them. Now the next one is the focal length of the eye lens is too long. And why does it happen? When the eyeball is going to contract itself. So the size of the eyeball is contract. So now the focus will at the after retina, or the lens here is going to be thin like this. Now it is not going to make itself stretch, or we can say अपने आप को thick नहीं बना पा रहा है. That is why the length, the focal length, that is focus of this particular eye lens is going to be too long. You know that when the eye lens is become thin, so focal length automatically become long and eye lens become thick, so the focal length become shorter. So this is the reason for that. Here, let us see the near point. Okay, so the near point for the hypermetropic eye is shifted. So it is shifted like this. So here what is happening? The thing that is here is not going to visible and it has shifted till here. So the light that is coming from this point is now going to focus at this. So this one is the near point now. Like this one is the near point now. Now he is able to see things from here. Seeing things from this position. You might have seen your Dadaji or Dadima adjusting the newspaper like this in this manner, so that they are actually adjusting the point, the near point at which they could see the things clearly. Because their near point that should be 25 centimeter is going to shift it from that point to certain beyond. So now the near point is this one. From this point, the light now get focused on the retina. But जैसे ही हम इससे थोड़ा सा इधर आ जाते हैं, all the lights get focused after retina now. So this is the near point. This is what? This is the near point for this hypometropic eye now. Okay, so now if the things that is present here or anything that is after this near point, their near point is now getting refract and focus at this point, that is after retina surface. Now the correction measurement for this one, you know that all the things are going to bend after. So what we need that thing should get bent before. An earlier bending is required because eye lens is become thin. Now thinness is making them the more focal length. So focal length is going to increase. That makes the thing to focus here. Okay, that is fine. Or we can say that here we can use one more convex lens that is helping to converge the light ray that is coming from this position to more, and converging it little bit extra is going to make them focus at the retina exactly. And now, so what is the diagram for that one? So here we are get help to make it focus on the retina. So let's suppose this was the thing that we need to see. Light ray that is coming from here is get refract through this man-made convex lens first, and it is get little bit converged. See, you can see that now they are entering into this natural lens, eye lens, and now from here they all are getting converged directly and focusing at the retina. So that is very good. But here the brain and eye could detect this image, like this is the object. For that, the image would be making at the near point only. It is not like you are seeing the thing here only. You only thing that we need to know that in case of myopic and hypermetropia, in both the cases, your near point and far point is going to be fixed. The things that you are not going to see, we are actually shifting that images up to that position. So here the near point is this one. So we are actually making this end dash to that point with the help of this external convex lens. So I hope you all understand it very clearly how the hypermetropia and myopic disease are working and what are the remedies that we can make out of it. So make them all these diagrams that I have shown you in myopic and hypermetropia. These are very important because in exams, these key points that I have shown you here are like the key points that you can write in your exams, and the diagrams here are very essential and you should get practice for these diagrams, that how the near point is going to made like this and the dashed lines are showing you the actual image, and that because it is virtual, this is because this is made at the same side here. That is why it is made up with the dash line. So you must be clear with all these little things. Arrows must be put here, but the diagrams for the particular disease, it should be like this. You need to make the near point one, then when the position gets shifted and when the object is standing far or near to that near and far point, according to that second diagram, and the third diagram is for correction. So all these three diagrams for both the cases are mandatory and you should practice them well for the exams. So let us see what is next. This is what the exactly diseases, myopia and hypermetropia. Let us see now presbyopia. Students, before moving towards the presbyopia, here we are having certain things that you need to discuss, that to solve the ray diagram questions for both hypermetropia and myopic, you are going to get the questions on that also. So for that, you know that lens formula is there and we are using lenses for correction of the myopic and hypermetropic eye. Yeah. So for that solving here, we are having certain things that you need to concern. That is lens formula is 1 upon f is equals to 1 upon v minus 1 upon u. But in case of myopic eye, you are using what lens? Which lens you are using? Concave lens. Yeah. So the object distance would be u is at the infinite at this position, because you know that in myopia you are not able to see the things that are very far. So let's suppose the very far thing up to what we cannot see. We cannot see up to infinite. So why we are not taking the things according to the largest point? Let's suppose कि आपको मिनिमम यहाँ तक फादर पॉइंट है आपका, उसके आगे आपको नहीं दिख रहा है, उसके आगे beyond that you are not able to see. Now what will you do that? For that, so from that particular far point, you are not going to see the things till infinity. Okay, now what if we want to see the things infinity? From infinity, that is coming light ray that is coming from the largest stars and the furthest star, even normal eye could see that. I am having a normal eye, and if I am getting a light that is coming from the billion light years from the very far star, so I am able to see that clearly. But the myopic eye is not able to see that thing because it is coming from infinity for him. Now, we should correct things according to the extreme position, according to the extreme case. So, what would be the extremist case for the myopic eye? It is infinity. यानी कि infinity तक उसको देखना हो, ऐसा correction करके देना है हमें. Now, you know that object distance from the lens toward this direction would be taken as the negative because it is coming in the opposite direction. So, U here is at infinite. So, we are considering that object which is standing in place of this position. We need to see that thing. And now, the image, where would be the image is making? This is the far point. So, this is what, like if the object is standing here, so it is the position where we have to make the image of this object. That is why we would always be the far point for the myopic eye. So, V here is at the far point. Again, we would be in this direction only. Okay, that is the negative one. And the focal length is negative in this case because according to that we are having object here, we are making images also here. So, the focal length we are taking, the lens here is this one. So, here for this case, for the concave lens, you know that the focal length would always be taken as the negative. This is what in case of myopic eye, and this must be keep remember to you people that while solving this lens formula according to the myopic and hypermetropic eye, so these are the key terms that should be kept remember. Now, according to the hypermetropic eye, what is happening? Now, you are not able to see things that is near to you. In this case, like in this case, you are not able to see things after this near point. So, the object that is could be standing what at the extreme position, कितना सबसे ज़्यादा पास वो object खड़ा हो कि वो हमें at least दिखना चाहिए according to normal human eye. You know that according to normal human eye, we are capable to see the things that is standing at 25 centimeter. Now, so we have to see if near point is here, so that thing that should be the object, the extreme position of the object could be taken for this condition would be 25 centimeter. That is why we have taken object distance कि 25 तक object खड़ा हो जाए तब भी हमें दिखाई देना चाहिए. So that is what the object distance. Now image again like in the same case of the myopic eye, hypermetropia में भी यही होता है. तो जो आपका object यहाँ खड़ा हो रहा है near to the eye lens, it is now going to shifted its image to this near point. Now the hypermetropic eye is able to see things clearly. That is why image distance is the V's, that is person's near point. Person का जो near point है वहाँ पे image बनेगी. So again the object and image distance is going to be in this direction only, so it would be taken as the negative here also. But the focal length, you know that in case of this one, this lens, that is convex lens, the focal length would be positive. So here also, if you need to, in question it is already given that the focal length is this, so you have to take it in the positive manner. Okay, so all these are the tips and tricks for solving questions, for getting the detection of the myopic and hypermetropic eye. Now let's move forward to the presbyopia.